So following on from the previous three videos, we got to this stage here. We were trying to sketch this function here, and then when we differentiated it gave us this here. Okay, and now we need to consider we now need to consider the interval. So far we know we guessed our graph will look something like this. Okay, and then you've got to, yeah, so we suspect our graph will look something like this and something like this. Okay, but we need to consider the intervals now. So starting from here, differentiate this, that will then give us this. So now we need to consider the intervals. So in this region here, if you sit down and think about it, f prime will be greater than 0 in this region here. Okay, and then in this region here, if you sit down and think about it, this whole thing here, f prime will be greater than 0. So meaning that the gradient climbs in this region, which it does. It seems like it because we guess our graph to look like this. So it is indeed climbing up, 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 up. And then here we suspect our graph looks something like this. And then it is indeed climbing up, 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 up. Okay, but don't forget, looking at the derivative here, the derivative breaks down when this thing here equals 0. So you see, dead on 0 here, it breaks down. So because the derivative is undefined, dead on x equals 0, we cannot say that the gradient is 0 at x equals 0. You see, we can say the gradient is 0 here. We can say the gradient is 0 here because it is defined here and it's defined here. So okay, so our graph looking like this, something like this here, we can say the gradient here is 0. And we can say the gradient here is 0 because it's defined. But here, something weird happens dead on 0. Looking at the derivative here, we cannot say the gradient is 0. Okay, but then in this region here, if you sit down and think about it, the derivative here would be less than 0. In this region here, the gradient, the derivative here would be less than 0. So hang on, what that means is, what that means is our graph looks something like this. Okay, bear with me. Will look something like this. So what that means is, looking at here, looking at this region is saying the gradient here is greater than 0. So look, it does make sense. Look, this gradient is climbing, 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 climbing. Looking at this here, the gradient is greater than 0. Look at this, climbing, 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 climbing. And then looking at this here, the gradient is falling, falling, falling. The gradient's getting low. Yeah, the gradient's falling, falling. And then here the gradient is falling, falling, falling. So look, in this region here, it's saying the gradient here is less than 0. So here in this region, it is less than 0. It's going downhill here. Okay, and looking at this here, you can see that here it's saying the gradient is negative, negative, negative. The gradient here is saying negative, negative. So, but the function itself. So this is a classic case where a lot of people think that, oh, it's the gradient's downhill, 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 downhill. So people will think that it's going downhill, downhill, downhill. They will think that the gradient itself is, sorry, the function itself is falling. But now in this case here is a classic case where the gradient is falling, falling, but the function itself is not actually decreasing. Look at this. The function itself is decreasing, decreasing here. We are talking about the function now, okay? The function itself is getting lower and lower and lower, but then all of a sudden it jumps. Now the function itself is higher, higher. Well, it is falling, but it's falling, but it's still higher than over here. But the point here is that the function itself here, it's decreasing up to here, but then it's decreasing, but over here it's higher than up here. So just because the gradient is decreasing, it doesn't mean that the function itself is always decreasing. Here the function is not always decreasing. Look, up here it's higher than here. So, well, think about it. It's quite confusing what I said, but it does kind of make sense if you truly understand it. Okay. Yeah. So okay. So our overall graph here will look something like this. Okay. And then now we need to look at the second derivative here, just to see if it caves down or caves up. So let's start with our derivative, our first derivative here. Okay, hang on. Start with our first derivative here, and then rewrite it as this. Okay, and then rewrite it as this. Now differentiate it. It will give you this. Okay, and then tidy up, it will give you this. So looking at this here, when x is in the negative realm, so when x is in the negative realm, when x is in the negative realm, our second derivative will be a negative, so it should concave down. So if f double prime is negative, then it should concave down. And indeed, looking at the function here, it does concave down. Look, see, concave down. And then in this region here, in the positive region, look at this. In the positive region, this thing here would be f double prime would be positive. So it should concave up. And looking at our graph here, it does indeed concave up. See? Okay, so everything tallies up. Okay, so you've got to consider f prime and f double prime. Okay.